most scientists don't really think about the metaphors they're using. They just use them. People said the brain works by hydraulics, or the brain's like a telephone exchange, or it's like a computer, which is the current model we work with. And they shape, but eventually come to limit what we can imagine, what we can think about how the brain works. And therefore, if in the past we've used technology and it shaped our understanding, what's going to happen in the future? At the moment, there's this tidal wave of data coming from imaging studies of the brain, from studies of the electrical activity of the brain, and that information is very difficult to integrate. And so people are saying, look, we don't have a theory. It's not good enough to say the brain is like a computer. We need something more complex.
Right. Smell research is only really a part of what you do, right? You have this whole other persona that you're a historian of science as well. You know, you're interested in how do we know things, how did we get to knowing these things, why did we investigate and go down certain routes to figure stuff out. I mean, looking through your sort of roster of work is really cool. And you just brought out 2 books at the same time.
Yeah, it wasn't the best time.
This year. Why? One was a smell book, and
one is called A Smell, a Very Short Introduction. It's one of those Oxford University Press very short introductions. There are hundreds of them on all sorts of different topics, and if you want to know basic information about any topic virtually that's to do with science, it's mainly science, but not only, my advice is to go and have a look at one of them. It's better than Wikipedia. And yeah, they're nice little books. They're about £8-9. So I brought that out on sense of smell, and then I published a very big book called The Idea of the Brain, which is a history of not only a history. It's divided into 3 halves. Well, 2 halves and then a final bit, past, present, and future. So it deals with how ideas about the brain have changed over time, what we currently think, the models that we're using, and a kind of very speculative bit at the end, saying what I think is going to happen in the future. And the key thing about it is that it's linking our ideas with technology, because that's what's happened. People have said the brain works by hydraulics, or the brain's like a telegraph system, or it's like a telephone exchange, or it's like a computer, which is the current model we work with. And these are technically metaphors, and they shape, but eventually come to limit what we can imagine, what we can think about how the brain works. So that's one of the things I've been exploring. It's not simply a set of discoveries, but it's also the ideas that people have had about how nervous systems function, about what the brain is doing. And therefore, if in the past we've used technology and it shaped our understanding, what's going to happen in the future? What's going to happen when technology changes? How will our current understanding alter? Because what sometimes happens is not simply that, is old findings are now reinterpreted in the light of the new model or metaphor that we've developed. So it's not that we're going to throw everything away, but rather the way we look at things at the moment will then alter in the future. And most scientists don't really think about the metaphors they're using. They just use them. They don't even think about whether they're quite old-fashioned. So I saw in a couple of years ago, an article in a leading neuroscience journal talked about the brain being like a telephone exchange, which is a metaphor that dates back to about 1880. And most people like you, I guess, don't actually know what that means. Telephone exchanges don't work in the way they used to. They used to work by people putting yeah, you go.
The women with the wires. Yes, okay.
Yeah, so it generally was a woman. It's an interesting kind of job. So the key point was that it was flexible, unlike the telegraph, where a message just goes between 2 points. In the telephone, the message could then be distributed in different places because you'd ask for one number or another, or it could even be sent on to a different exchange and then eventually you'd get through to your number. So what this scientist was getting at was the flexibility of the telephone exchange. But I was just struck, this is an amazingly old metaphor that he's thrown out there, not really the one that I was expecting. So what will happen when you talk to scientists and you explain to them, look, your way of thinking is, yes, it's a framework, but a framework can be a cage, can limit you. You can't literally, it's not a box, but you can't think outside the frame. They then get very excited because they say, okay, that's amazing. So what's the future going to be like? What's it going to be? Big thing, to which I have absolutely no idea. If I knew that, I'd be very rich.
You would have sold millions of copies.
All you can say is that it will change in the future.
Yeah, because as we develop more complicated things, we are able to sort of, and we learn more about what the brain can do, we were able to sort of say, oh, well, you know, it works in this sort of like complicated, multifaceted way. And you said like now we sort of talk about the brain as a computer, and we also talk about things that don't actually have brains as having like, oh, well, that's its computer, that's its brain. Sort of, it goes both ways, right? But I mean, do you agree with that? Do you think that that is a good metaphor for it? Because computers, they're great, but I mean, the sort of most interesting thing that we have at the moment is the internet, right? That's what makes computers really interesting, and that works a very, very different way.
There was a brief mode in science for talking about the brain as being like cloud computing or something. It didn't last. It lasted a couple of years, and people thought, well, it doesn't actually help us. So that they tend not to think about that, because one of the things about the internet and the way it was designed, you've got to remember the internet was designed by the American military, and the idea is that it could, any of the nodes by which all the computers are connected could be destroyed by a nuclear attack. This is their thinking, and the whole system would still function. Now, there is an element of that in your brain, but clearly we can see from traumatic brain injury or stroke that there is also some localization of function. That is, if you have a stroke on a particular, in this part of your brain, then you're very likely to lose your ability to speak. So there is localization of function. One of the odd things is that it's also distributed. So I guess the brain is somewhere in between or the best way we've got of thinking about it at the moment, let's say that, is somewhere in between a computer with its ability to process information and then this kind of distributed but also localized aspects of cloud computing and the internet. I mean, the key point is this has been incredibly productive. So this metaphor of the brain is like a computer, or initially, in fact, the computer is like a brain. That's the fascinating thing. This came about in the 1940s, 1950s, and the first digital computers were designed on the basis of a particular theory that was developed about how nervous systems function. They don't in fact function that way, but neuroscientists came up with this model for how neurons were connected together, arguing that such a network would be able to process basic logical arguments like and, if, not, or. Anybody who's done any computing will recognize these as options. You know, if this, then I do that. And they argued that this was how the nervous system was built. And John von Neumann, I mean, most of your listeners will probably have heard of Alan Turing, but Turing, whilst he was very important, and I'm from Manchester, so I'm happy to big him up, the devices that we're all using are not Turing devices. They're all built on an architecture which was developed by a man called John von Neumann, who was a physicist in America. And he develops the digital computer. And his starting point, when in 1945 he said to the American government, right, give me a load of money, I'm going to build you a supercomputer. Yeah. His starting point is, I'm going to build it like a nervous system. So at the start, initially, the computer was like a brain. That didn't last very long because he realized that, in fact, brains aren't wired up like that. But that was his inspiration. So in
these kind of like, there's these attempts at biomimicry where we sort of try and take inspiration from what is happening out in nature and invent something from it. Sometimes we get it wrong and then just invent something completely new and it still works.
Yeah, I mean, it was wrong but right. And the proof is what we're doing now. We wouldn't be able to have done that without von Neumann having this idea.
Yeah.
So from the 1950s onwards, we thought of the brain as being like a computer. And I mean, the power of that metaphor is undeniable, because that's 70 years of, hundreds of thousands of researchers of an incredible insight. But what's clear is that at the moment, there's this, people often refer to it as a tsunami or a tidal wave of data coming from imaging studies of the brain, from studies of the electrical activity of the brain, or from what are called connectomes. So you're working out the wiring diagram of the brain. And that information is very difficult to integrate. And so people are saying, look, we don't have a theory. It's not good enough to say the brain is like a computer. We need something more complex.
Right,
so at the moment, there's a lot of talk in the journals that we're kind of stuck. We're getting to the end. That's my sense, is that we're pushing against the limits of this metaphor, because the technology can't help us anymore. It may be that we just need a new theory. Past experience would suggest that is likely to come from technology, but it might not. It might just come from some very smart people figuring stuff out. And as the final part of my book explains, there are lots of very clever people who think they've done that. What's striking is that none of those ideas have anything like a kind of majority support. And although science isn't a voting system, in general, we kind of, when things are clear, we group around, this is our current vision of the world.
Right,
and it's nothing like that at the moment in Europe.
Wow. So it's really unexpected that science and our sort of understanding of the human brain would at one point go further and be more advanced than the technology that's out there in the commercial world. I would never have put my bet on it going that way around, but
well,
yeah,
I don't know if we will. I'm just saying that's an option.
Yeah.
So,
yeah.
And it's partly accepting that there are very clever people who insist that they're right, and I don't necessarily have the means or the desire to say no, you're not. All I can do is observe that, well, you haven't convinced your peers yet. But it's possible that some of these ideas may turn out to be right, and we will develop a new framework. But what I was trying to get at in the book is simply when I was writing it, my editor said, so how does the brain work? And I said, I've no idea. He said, you can't say that. You've got to have an answer. That's what the readers want, an answer. And I said, well, I can't give you one. So, there are loads of books. You go out and you'll find any number of books that say the brain works in this way, and self-help books explain this, that, and the other, and it's just not true. So partly what I was wanting to do was, apart from to tell the story of how we got to where we are, I also wanted to explain for the lay reader, the everyday reader, the kind of conversations that neuroscientists have in conferences where they go, we don't know anything, do we? And everybody goes, nope, haven't got the foggiest idea. So I was kind of pulling back the curtain and saying, look, this is really what's going on. We don't know. And indeed, people are arguing about how to interpret even quite simple bits of information. There are some people who are... So one of the basic ideas that's been around for a century is that, and I've used it, I think, in talking about the sense of smell, is that neurons contain something like a code, the way they represent the outside world. And there are neuroscientists who are saying, no, that's simply not true. That's our interpretation of it. It's not actually anything like a code in any real sense of the word. So a lot of the basic, and again, it's a metaphor. Code is another metaphor. It's not, just like with the genetic code, it's not actually a code. It's simply a way that biology has found of doing things.
Yeah, you can't actually go in there and have a look and see the tea and take it out, that kind of thing, right? It's exactly like you were saying, the metaphors of the past had limits, and that's why we've sort of moved on and had new ones. And to recognize that we'll always have, always be so much that we don't know. And really every time we find something out, we sort of realize all this other stuff that we don't yet know yet, and start asking fresh questions, right? Did writing this book sort of inspire any new questions for you about your smell research?
Well, it may, this last point that I mean, in fact, one of the things about the book is virtually, the brain book is virtually nothing about smell in it. I mean, I was,
But that's interesting, because smell is so closely tied with like our memory, right? When we think of like, we can, I can look at a tree and I can know that's a tree as soon as I see it, but I could smell a tree and be like, wait, hold on. Or it smells like outside. Do you know what I mean? Like it's a strange.
yeah, no, absolutely. Yeah, so that's one of the powers of smell, is to take you back to a particular place. If you smell something, I don't know, your grandmother's cooking, you smell a spice that she used or something, and it's not just, oh, I remember Granny used to make whatever, but you're back there. You are back as, that high, looking up at it in the kitchen, and it's almost like you can look round and see everything. So it's this very special kind of memory. I mean, there were lots. So smell was one of the reasons why I didn't go into it in much detail, is that we know a lot less about it than we do about vision. So there's a lot more about vision in the book, and that's been the main way that we have concentrated on understanding the brain. And I've got a colleague. In fact, I've got a book here. I'll plug her book.
Oh, great.
I've got a colleague, a neuroscientist and a philosopher, called Anne-Sophie Barwich, and she's produced this book called Smellosophy: What the Nose Tells the Mind. Ooh. And she's interested both in the neuroscience and in the philosophy of smell. And so she tries to show how, because we've been looking at the brain primarily through visual studies, we've missed out a lot about how it works in the chemical senses. And I think she's absolutely right. So this is a highly recommended book, Smellosophy.
Yeah, I'm totally going to pick it up. That looks so interesting. So, but I mean, really, though, we know so very, very little about why that is the case with smell and memory and
well,
do we know?
What we do know is, I mean, this goes back to what I was saying about the wiring diagram being common. So when you identify any brain, so whether it's a maggot brain or yours, you identify a smell, and then basically you do your brain sends the signal two ways. It sends it to centers of the brain that determine, well, how am I going to respond to this? Is this a smell I like? Is it a smell I don't like? Is it a smell that represents danger, attraction, or whatever? And then you behave in an appropriate way. At the same time, the signal goes up into the memory processing centers. So, and that's the same in a maggot as it is in you. So there is this very close link, and it seems like your sense of your experience is being tagged with whatever you're smelling at the time, and in particular significant events may get tagged with the smell. So you've got the memory, and by activating the smell you can kind of pull that memory back, and it comes back into your mind in ways we don't fully understand. But there's this, as you're just behaving, doing stuff, your brain is making sense of the world and saying, I'm in this particular place, and also these are the things I'm smelling. And this is much more powerful than hearing. We don't fully understand what's going on, but it seems that place and smell are very closely, a sense of place and a sense of smell are very closely connected. And as I said, that example of being back in your grandmother's kitchen, it's not just you remember your grandmother's cooking, but you are in a particular place. And there's this ability to reactivate memories using smell as kind of a probe to make it happen.
It's so fascinating how our different senses are sort of like how we intake them and deal with them all differently. And I guess it sort of gives us a better range of ability to detect our world, right? If everything went into one big same processing place and was dealt with equally, then we'd be at disadvantages in other areas. So I'm sure there is an amazing evolutionary purpose for why you know, each pot has each sense goes to a different pot. And I mean, because as you were saying with hearing, you can sort of recite the lyrics to a song without having to think about it, a song that you heard like 10 years ago without having to think about it, almost perfectly for many of us. And yet, you know, try do that with a book that you read, and that's never going to happen, you know.
We might be able to do it with the poems. So it's partly to do with the rhythm of how it's constructed. But unless you've learnt it was the best of times, it was the worst of times, and I can't remember how it goes after that. I mean, that's the opening to Tale of Two Cities. You may know the opening sentence, but you know, you don't know much after that unless you've really sat down and learned it.
I don't know if you know this, but as someone who's, you know, been obviously very interested in the brain and how we learned about it, when they show up on you know, when they try to display how different parts of the brain respond to different things, and it shows it lighting up. Obviously, it's not actually lighting up, but what is that? What are they detecting in MRIs and things like that? How are they detecting? What is this activity that they're?
It's the amount of blood. It's the blood oxygen level detection. It's called BOLD, bold. Oh. So all it's saying is that the cells in this particular part of the brain are doing something. We don't know what they're doing, but they're doing something. There's more oxygen flowing to that particular part of the brain. So it's not actually telling you what the cells are doing. It's telling you what the blood vessels around them are doing, the oxygen they're transporting. So, I mean, there's a big argument. Neuroscientists, I mean, so people who work on fMRI, these are the scans that you see people's brain lighting up when they're thinking of playing table tennis or something like that.
Yeah. Okay.
The people who work in this area are very convinced by it. I think many neuroscientists, and I gave some examples in the book, are pretty doubtful, partly because, I mean, you know, I study single neurons. Mm-hmm. Now, each of those, the smallest square in one of those images has over 5 million neurons. And we don't know what they're doing. We just know they're doing something. So I can tell you, well, my neuron is activated, it's inhibited, it's got this particular shape. Whereas in an fMRI, all I can say is, well, there's something happening there. That's it.
Is this where this idea?
So there's been a lot of argument about this.
Sorry, yeah. Just that. Is this where the idea of different parts of the brain handling different things, like our memory sits over here, and you know our emotional response sits over here? Is that where that sort of?
Well, it goes that goes back centuries. That idea goes back centuries.
Yeah.
There's something that's called phrenology, which was the idea that you could feel the shape of the brain through the skull, which of course you can't because the skull's quite thick. But by feeling different lumps, you'd be able to detect different organs in the brain, and that different organs did different things. Yeah. So, I mean, phrenology was widely accepted. Karl Marx believed in it. Queen Victoria believed in it. So that just gives you an indication of the difference in political views, and you could still think that this was interesting. Virtually every intellectual in Europe and America in the 19th century accepted this. If you read Conan Doyle's Sherlock Holmes stories, the first time that Holmes meets Moriarty makes a very rude comment about the shape of his head, because he was saying, well, this shows you're stupid. So the idea that different bits of your brain do different things goes back to this idea. And it's that phrenology is nonsense, because you can't tell anything from the shape of your head. We do know that, for example, as I said earlier on, this part of the brain here, which I'm using now, is involved in speech production. So if I damage this area, I won't be able to speak. If I have a stroke, for example, it will damage my. So there is localization of, it's not language perception, because that's somewhere else, partly, but it's production of speech. So it's a mixture of muscular control and then weird things that we couldn't actually define very easily about desire to speak and all the rest of it. But that's there.
Yeah, so there is a sort of they're right in a sense that there's groupings of activity, and we know that because of it being taken away.
But these areas are also deeply connected. So increasingly, researchers are interested in the interconnections between these areas. So even something like vision, which is processed primarily at the back of your head, and if you damage that, you can't see properly. But the cells there are also responding to auditory stimulation. And even my smell cells, we've discovered in the last few years, my smell cells, which are dangling down, their activity is altered by influences from other parts of the brain, from other regions. So it's not, again, it's why the brain isn't a computer. It's not like you've got an input going to a processing area and then it gets sent on. That input is altered and nuanced by context. So yeah, it's very complicated.
Yeah, it's very complicated. It's so amazing.
So there is localization of function, but there is also, it's also distributed, and that localization, the closer you look at it, is very blurred.
It's incredible that you have this great knowledge and, you know, this drive to write history of science books as well as you're studying. You're a bit of a polymath, I guess, in that, right? Yeah. What's next for you? Have you got an idea about what might take your fancy next?
Oh yeah, I'm about 3/4 through a book about it's a social history of genetic engineering, so of our attempts to manipulate other organisms. And so it's as much about how that's been seen by society and the fears that have been generated, as it is about actually how scientists have gone about and done that, and then companies have tried to apply that. So this was partly motivated by the fact that there's a technology called gene drives, which is a way of changing a gene, say in a mosquito, and that gene would then multiply itself such that if you were to release it, it would go through the population very, very quickly. So we have the potential to manipulate ecosystems. And I find that very frightening. So I'm very frightened by that. But I also know that when people first developed the ability to manipulate microbes, people were terrified by that as well. 50 years ago, there was huge worry. The scientific community was so terrified of what it was doing that they organized a cessation of research. They said, right, nobody's going to do any research for the next year while we work out how to make it safe. And all those fears turned out to be fears, fantasies. There wasn't any danger. So I wanted to try and work out whether my fears about gene drives are justified, or whether I'm simply repeating these kind of deep-seated cultural fears that have repeated themselves over the decades.
Yeah, I mean, people comparing it to vaccines, right? People, you know, saying that there was a big fear about vaccines. Obviously, there still is for some people, but I think what you mentioned earlier, the difference is, and there is a Netflix series that just handles this so well. I'm sure you've seen it. What are they? Is it Coded or something like that? I think it is. That handles this so well.
Called, but yeah.
Yeah. But it's the wider ecosystem effect, right? As you said, it's the fact that once you put it out there, it starts to have a ripple effect with other species, and who really knows? Who knows how far it goes? That's the fear, right?
Yeah, but as I say, that's exactly what terrified people in the 1970s.
Yeah.
So I'm wary of my responses, but the only way I can work that out, and I don't know what the answer is because I haven't got to that bit yet. The only way I can work this out is by going through it. I mean, it's the same thing with GMOs. You know, people are very worried by GMOs. There is evidence that some of these, the characters that we've put into crops are getting into the local races of plant, in particular in Mexico. This is the case with maize in Mexico. How problematic that is another matter. I'm not worried about eating GM crops. I don't think there's any danger about that. But there is this potential for unexpected ecological consequences that we need to be wary of. So that's partly what interested me, was this continual fear which moves its target. As the target changes, the fear comes with it. And I wanted to try and get to where that was coming from, whether it was rational or whether there was something deeper in people's psyche, and including mine. But as I say, I don't know what the answer is yet.
Well, I'll come back to you maybe in like a year or so when you've finished, and we can have another chat about that.
That'll be out in spring 2022. So we've got a while to go. I've got about 6 months to finish it.
You've got time to figure out what the answer is. I'm not. I guess it's human nature to be afraid of the unknown, particularly when it's not in your hands, right? We can vote and we can try and influence policy, but at the end of the day, for a lot of people, it's a decision being made by a small group of people for a very large group of people. And the more we become globalized and trade with each other and travel around, and as COVID has shown us, we are all one and the same, interconnected. These decisions become much more vital for all of us. So, very interesting, great topic. I'll be very interested to talk to you again. Then, thank you so much for your time.
You're very welcome. I'll happy to come back and talk in 18 months.
Yeah, that sounds great. I'll send you another email. Awesome. Thank you so much.
A lot of people have reported that previously nice smells now smell like petrol or something weird, or that they may be able to smell things that they can't name. You've got about 4 million smell cells in your nose. So if you imagine that a smell is a bit like playing a chord on a piano, got a lovely C major chord, and then if you imagine now one of the keys doesn't work, or you've connected it to a completely different note, when that chord comes along, it now makes a discordant, unpleasant, perhaps a sound that you never heard before. And so that's the kind of thing that's happening in your nose when you get damage to it, either by physical damage or by disease.